All right, so here's where the rubber hits the road. How pain is controlled. So we had our example of hitting the thumb with a hammer, withdrawal reflex, yelling, that's our limbic contribution, applying pressure to the injured thumb. And gate theory, which I think I said this last quarter too, I call it the mom with two kids theory. So the mom can only listen to the kid who's yelling the loudest. So if the A beta fibers are yelling louder, then it reduces the pain. If the A delta and C fibers are yelling the loudest, you have more pain. I can't remember if I watched that, if we had that animated video on gate theory. I think we did in modalities. It's kind of goofy, but it explains it pretty well. So the idea was that the transmission of pain is blocked in the dorsal horn, closing the gate to pain. And then more information's been revealed in later investigations, but the gate theory was important because then people started looking more into the mechanics and control of pain. So TENS is the clinical application of some of those subsequent investigations. And as you all know by now, TENS uses electrical current applied to the skin to interfere with the transmission of pain information at the dorsal horn. So, cool stuff, right? So the counter-irritant theory is the sort of the more detailed interpretation on the cellular level of how nociceptive signals are inhibited by stimulation of non-nociceptive receptors and occurring in the dorsal horn of the spinal cord. So circuits in the dorsal horn that may produce inhibition of nociceptive signals, the collateral branches of mechanoreceptive afferents stimulate interneurons that release enkephalins. So enkephalins binding to the transmission of nociceptive messages by primary afferents and interneurons. So basically it's an ascending control using those natural endogenous pain relief chemicals. So our A beta fibers stimulate the interneuron that releases enkephalin that inhibits the information in that spinothalamic tract. Okay, so we'll go through all these again. So our anti-nociceptive systems, we're going to talk about them as 5 different levels of anti-nociception, and they happen in different areas of the nervous system. So anti-nociception is the suppression of pain in response to stimulation that would normally be painful. So the endogenous substances, so naturally occurring substances that activate anti-nociceptive mechanisms are called endorphins. I think we've all heard of endorphins with runner's high and all that stuff. Endorphins include enkephalins, dynorphin, and beta endorphin. Endorphins are pain-blocking opiates. They bind to the same receptor sites as pain-blocking opiates, and so the receptors are sometimes called opiate receptors. But really, those receptors were originally meant to bind to those endogenous substances to activate antinociceptive mechanisms. So this is our 5-level model, and this is in Chapter 7 on page 136. Pain can be altered at any of these locations. So level 1 is in the periphery. You can alter pain in the periphery, and we're going to talk about how you do it in each level. You can alter pain at the dorsal horn, and that's our counter-irritant theory. That's level 2. Level 3 is a descending control. It's a fast-acting neuronal pathway from the brainstem, from the periaqueductal gray area, the locus ceruleus, and the raphe nuclei. Those are nuclei in the brainstem that have a descending pain control. There is a hormonal pathway activated in the by the hypothalamus. The pituitary gland produces beta endorphins, and the adrenals also produce beta endorphins. So that's a descending pathway. And then there's descending cortical inhibition. And so that's when the cerebral cortex decides you're not going to have pain. So that can be, lots of different things can cause that. Education can cause descending cortical inhibition. Fear or stress can cause it, or like athletic competition. People do amazing things and overcome amazing pain because they are competing at that level, and that's descending cortical inhibition. So interestingly enough, in that Adrian Lowe workshop, when they were talking about children, there are studies that show that children that engage in contact sports have a higher, have fewer reports of chronic pain and widespread pain in later years. And it has to do a little bit with being celebrating pain and being rewarded for pain rather than being punished for pain or feeling punished by pain. So like kids who play football, he gave the example of his son would come home and go take off his pads and go, look at this bruise, Dad, I got this awesome bruise. And even though it's a bruise and it's painful, to him it symbolized being part of the football team and being included. And so it was a positive thing. It was a positive response to pain. So that positive response to pain by children participating in contact sports sets them up for less pain later in life. On the other hand, infants in the neonatal intensive care unit who are being given injections and stuff, later in life tend to have more amplified responses to pain, because before they're even able to process that information, they're receiving pain. There's no reward for that, you know, from the level of perception that they can have, and so they tend to have amplified responses to pain later in life. Very interesting. So we're going to go through each one of the levels of anti-nociception. So in level 1, it happens in the periphery. This is where aspirin and other non-narcotic analgesics like ibuprofen and that sort of thing work. They work in the periphery. So what they do is they decrease synthesis of prostaglandins, and prostaglandins act as neuromodulators which sensitize nociceptors. So when you take away those prostaglandins with the aspirin or the other non-narcotic analgesics, it prevents nociceptor sensitization and it reduces peripheral pain. So that's how that works. Pretty cool, right? So topical menthol like Bengay or Icy Hot and capsaicin also desensitize nociceptive C fibers. So this is focused pain control at the periphery. It does not have an effect at the dorsal horn. So any topical method like the NSAIDs and aspirin, non-narcotics, and those topical menthols and capsaicin help desensitize nociceptive C fibers. The NSAIDs do it by decreasing the synthesis of prostaglandin, which are neuromodulators, and they prevent nociceptor sensitization. Pretty cool, right? Level 2, that's our counter-irritant or our gate theory, which happens at the dorsal horn of the spinal cord via local inhibitory neurons releasing enkephalins or dynorphins. It's the level of counter-irritant effects, heat and TENS. Inhibition of pain, nociceptive signals, using stimulation of non-painful receptors. Both the signals travel to the dorsal horn of the spinal cord. The A-beta fibers stimulate the interneuron with the neurotransmitter enkephalin, which binds to receptor sites in the pain, the nociceptor system, and inhibits the transmission of pain. So it's presynaptic inhibition with the binding of those enkephalins. Pretty neat, huh? So on the pressure on the hammered thumb stimulates mechanoreceptors, those A-betas, which release enkephalin, which causes the interneuron to release enkephalins, which bind with pain receptors, which inhibit transmission of pain signals, and decrease release of substance P, which is also a neuromodulator functioning in pain pathways. So there's this video. It's like a little short of 2 minutes long. It's actually an ad for BioFreeze, but it actually describes the counter-irritant theory pretty well. And menthol, which is also in BioFreeze, also works at level 1. So even though this video is an ad for BioFreeze, I mean, I like BioFreeze and everything, but I don't generally like to put in videos that are ads, but it does such a good job of describing the counter-irritant theory that I included it. Again, optional to watch. So level 3 in the anti-nociceptive 5-level pain model is the fast-acting neuronal descending system from the brainstem. The raphe nuclei in the medulla projects axons to the spinal cord, releases serotonin to interfere with the pain message. The periaqueductal gray area in the midbrain activates the raphe nuclei. The locus ceruleus in the pons inhibits spinothalamic activity. So spinothalamic is that fast pain in the dorsal horn by binding norepinephrine on the primary afferent to suppress substance P. So it's desensitizing. It's a descending system. There is a little video on level 3, anti-nociception. So what I want you to know for each of these levels is it ascending or descending, and where the effect happens. So with the level 1, the effect happens in the periphery, and it's an ascending thing, and it desensitizes nociceptive fibers. Level 2 happens in the dorsal horn. It's ascending, and it's those competing pathways, A beta versus A delta and C fibers. Level 3 happens in the brainstem, and it's a descending system, and it causes release of neuromodulators and neurotransmitters, which inhibit spinothalamic activity. Level 4 is a hormonal system. This is also descending. It involves the periventricular gray area in the hypothalamus. The pituitary gland releases beta endorphin, and the adrenal medulla also releases beta endorphin. Low frequency TENS and acupuncture may act on this level. Remember when we did the 1 to 10 megahertz, that low frequency TENS, and we got just a little bit of muscle contraction? That might activate level 4. It's not proven, but that's the theory, that's where that acts. It's a descending system. It happens in the hypothalamus, pituitary gland, and adrenal medulla. Level 5 is the cortical system. So this involves our cerebral cortex. Expectation, excitement, distraction, and placebo all may play a role in adjusting transmission of nociceptive signals. So we're using our higher functions, our cortical function, to adjust the transmission of nociceptive signals. The placebo activates the same higher order cognitive and brainstem areas activated by opiate drugs. So we can have an effect. This is sort of the same effect of like the mom pulling the car off the baby or something like that. There's something going on that is overriding all those influences and allows us to do things that we wouldn't normally be able to do. Also, distraction and placebo effect act on this level. So it's a descending level. The cerebral cortex adjusts transmission of nociceptive signals. Pretty interesting. It's also stress-induced analgesics, where stress triggers pain inhibition systems. So I was talking earlier about the lady in the chronic pain program who had a lot of stresses in her life, and it was causing more pain. Stress can also trigger pain inhibition systems, stimulating activation of the brainstem, the neuronal descending system, hormonal pain systems, and the cortical descending system. The pituitary gland releases endorphins in the hormonal system. The brainstem releases pain-inhibiting neurotransmitters. And so accidents, disasters, athletic competitions, like I talked about earlier, those can all affect the decreasing pain signals. So pro-nociception is the opposite of anti-nociception. Pain transmission can be controlled at several levels. It can also be sensitized at several levels. Edema and endogenous chemicals can sensitize free nerve endings in the periphery, like those prostaglandins and histamines. Those can sensitize free nerve endings in the periphery and cause more pain. When a person is anxious or depressed, that can upset your chemical balance and cause more pain. Pro-nociceptive pain matrix activity can also produce pain in the absence of nociceptive input. There was a study done of social exclusion where people were isolated from other people, and brain activity changes during physical pain, actual tissue damage, physical pain, can be the same as during social distress. So if somebody's socially ostracized or feels socially ostracized, it can actually cause the same brain activity changes that physical pain can cause. So really interesting, all the effects that can increase or decrease pain. So this is a chart from the book, and I don't want you to memorize it or even read it. I just want you to get an idea of things that can happen to influence pain. So the orange on the chart indicates pro-nociceptive brain areas. The purple indicates areas that are can be both pro or anti-nociceptive, and the yellow is areas that are anti-nociceptive. So just know that some areas can do both, some areas can do one or the other, and it's all mixed up with what's going on in our body. So really very, very amazing systems here. Very interesting stuff that's going on with pro-nociception and anti-nociception. There is a functional MRI image in the book on page 133, which shows different areas of the brain being activated. Pretty interesting. In the next section, we are going to talk about types of pain, and then that's going to continue on into chapter 8.